Mount Semeru is detonating, not once, not twice, 106 times in a single day. On February 9, 2026, seismic instruments buried in the flanks of Java's tallest volcano recorded an explosion roughly every 14 minutes from dawn to midnight. Ash columns punched 900 meters above the summit crater, visible from towns across East Java. That rate of explosive activity placed Semeru among the most intense volcanic episodes recorded anywhere in Indonesia in recent years. 5 days later, on February 14th, a series of eruptions sent pyroclastic flows, superheated avalanches of gas and rock exceeding 1,000 degrees Celsius, racing 6 kilometers down the southeastern flank toward the same villages that were devastated just 4 years ago. The alert level now sits at level 3, 1 notch below the maximum, and the volcano shows absolutely no sign of slowing down. The question facing Indonesian authorities is no longer whether Semeru will erupt again. It erupts every single day. The question is whether the next dome collapse will push those pyroclastic flows, the full 13 kilometers, to the communities that lie directly in their path, and whether the people living there will have enough warning to survive. The trigger for the current crisis arrived 3 months earlier. On November 19, 2025, at 14:12 local time, pyroclastic flows began cascading down Semeru's southeastern flank. This was not a single blast, but a sequential event that built over 4 agonizing hours. Muhammad Wafid, head of Indonesia's geological agency, described flows that progressively lengthened throughout the afternoon. By 14:12, they reached 4.5 kilometers. By 15:25, 5.5. Then at 1600 hours, a massive eruption drove an ash column 2,000 meters above the summit. By 1630, the flows had extended to 6.5 kilometers. Indonesia's Center for Volcanology and Geological Hazard Mitigation, known by its Indonesian acronym pvmbg, raised the alert from level 2 to level 3. But within 60 minutes, the situation deteriorated further. Pyroclastic flows reached the Gladak Perak Bridge in Sumberwula village, 13 kilometers from the summit. pvmbg escalated directly to level 4, the highest classification in Indonesia's system, meaning residents must evacuate immediately. 3 people suffered severe burns. 137 climbers were evacuated from the Ranu Kumbolo camping area high on the mountain's slopes. Over 1,100 residents reached emergency shelters across the regency. The flows ultimately extended to 13.8 kilometers, tracing the exact corridor devastated in Semeru's deadliest modern disaster. Lumajang's regent declared a 7-day emergency response. The alert held at level 4 for 10 days before being lowered back to level 3 on November 29th. But Semeru was not winding down. It was reloading. To understand why volcanologists treat this mountain differently from almost any other on Earth, you need to understand what Semeru actually is and why its geology makes it uniquely dangerous. Rising 3,676 meters above sea level, Semeru is the highest point on the entire island of Java, Indonesia's most populous landmass. The Javanese call it Maha Meru, the Great Mountain, named after the sacred Mount Meru of Hindu and Buddhist cosmology. It sits within the Bromo Tengger Semeru National Park in East Java, with Mount Bromo's famous caldera lying roughly 20 kilometers to the north. Semeru is a stratovolcano, a steep-sided composite cone built from alternating layers of solidified lava, hardened ash, and volcanic debris accumulated over approximately 100,000 years during the late Pleistocene period. Its estimated total volume is roughly 60 cubic kilometers of material. The active crater, called jonggring seloko, measures roughly 500 by 600 meters across and contains a lava dome that has been continuously growing and collapsing since 1967. That single geological feature is what defines Semeru's particular danger. The dome grows as fresh magma pushes upward from the chamber below. Sections become too heavy, too steep, too unstable. They collapse. The resulting pyroclastic density currents, fast-moving avalanches of superheated gas, rock fragments, and volcanic ash, funnel down the southeastern flank along the Besuk Kobokan River Valley, directly toward populated communities sitting just 9 to 13 kilometers from the summit. Then the dome rebuilds, and the entire lethal cycle begins again. Semeru also emits between 21 and 71 tons of sulfur dioxide gas per day during normal activity, with each individual explosion releasing between 200 and 500 kilograms of the compound. When emissions spike above those baseline levels, it signals fresh magma ascending toward the dome, increasing the probability of a larger collapse event. The engine driving this process lies deep beneath the surface. Semeru sits on the Sunda volcanic arc, a 5,200-kilometer chain of volcanoes generated by the Indo-Australian plate diving beneath the Eurasian plate at approximately 75 millimeters per year along the Java segment. The subducting oceanic crust beneath East Java is ancient, between 100 and 140 million years old, and descends at a steep angle of 49 to 56 degrees. This near-perpendicular convergence drives highly efficient magma generation through partial melting of the mantle wedge at roughly 100 kilometers depth. Semeru's magma is classified as basaltic andesite, with silica content between 56 and 59%, producing eruptions that alternate between near-continuous strombolian explosions, averaging every 20 to 30 minutes during active phases and periodic more violent volcanic bursts. It is those volcanic episodes that generate the deadly pyroclastic flows, defining this volcano's threat to human life. The statistics alone are staggering. Semeru has not simply been active in recent years. It has been erupting almost without interruption for nearly 6 decades. The Smithsonian Institution's Global Volcanism Program records the current eruption phase as beginning in 1967, making it one of the longest documented open vent eruptions anywhere on the planet. The first historically recorded eruption dates to 1818, and since then, at least 61 eruptive periods have been documented, 11 of which caused fatalities. The volcano has been active in 93 of the last 127 years since 1900. In 2023 alone, pvmbg recorded an extraordinary 29,131 individual eruptions from Semeru, ranking it the single most active volcano in all of Indonesia that year. The average output during intense phases amounts to an explosion every half hour, sustained around the clock, week after week, month after month. Semeru's recorded history is punctuated by lethal paroxysms that follow a deeply troubling pattern. The deadliest eruption before the modern era struck on August 29, 1909, in what Dutch colonial records called the lumajang disaster. Pyroclastic flows and lahars killed over 200 people and destroyed 38 settlements across the region, burying hundreds of hectares of farmland. On May 14, 1981, heavy rains caused the summit crater lake to overflow, generating catastrophic lahars, volcanic mudflows carrying enormous volumes of debris that killed at least 251 people across 26 villages in 6 sub-districts. In 1976, another eruption claimed 119 lives. On July 27, 2000, 2 pvmbg volcanologists were killed in a summit explosion while conducting fieldwork dangerously close to the active jonggring seloko crater, a reminder that the mountain does not distinguish between those who study it and those who live beneath it. Then came December 4th, 2021, the eruption that changed everything. At 1450 local time, heavy monsoon rains eroded the lava dome at Jonggring Seloko, triggering a collapse that sent pyroclastic density currents racing down the Besuk Kobokan drainage toward communities on the southeastern flank. A towering convective plume rose to approximately 15 kilometers altitude, visible across all of East Java. The flows struck communities that had no standardized evacuation procedures in place. Indonesia's National Disaster Agency, BNPB, confirmed at least 57 deaths, though recovery efforts continued for months afterward, with sand miners in Sumberwula village still finding remains through September 2022. Independent tallies place the total as high as 69 fatalities, with at least 5 people never recovered. Over 100 people suffered injuries, many with catastrophic burns from the superheated material. More than 10,600 residents were displaced to evacuation shelters across the Regency. An estimated 5,200 homes were damaged or completely destroyed. The Gladak-Perak Bridge, a critical transportation link between Lumajang and Malang regencies, was obliterated by the flows. Agricultural losses covered more than 800 hectares of productive farmland, with livestock casualties including at least 138 goats and 23 cattle. 24 schools were damaged, disrupting education for nearly 4,000 students. Total economic damage reached 310 billion rupiah, though academic estimates suggested the true figure exceeded 500 billion when accounting for long-term agricultural and infrastructure losses. A significant controversy followed the disaster. pvmbg had classified the event as a secondary eruption triggered by rainfall eroding the dome rather than a primary magmatic event, and as a result, the alert had remained at level 2, even as the pyroclastic flows were burying villages. Community leaders in Sumberwula and Supaturong later confirmed that no formal evacuation procedures had existed at the village level when the flows arrived. But what happened exactly 1 year later fundamentally rewrote the survival calculus for communities living in Semeru's shadow. On December 4, 2022, a near-identical mechanism produced another major eruption. Heavy monsoon rains again collapsed the lava dome, generating pyroclastic flows that traveled 12 to 13 kilometers down the same southeastern corridor and ash plumes reaching 15 kilometers altitude. The alert was raised to level 4. Yet this time, not a single person died. Residents had learned the brutal lesson of 2021 and began evacuating themselves before any official order was issued. Approximately 2,000 people reached emergency shelters at 11 locations across the Regency. Houses in Sumberwula and Supaturang were again buried to their rooftops, and the rebuilt Gladak-Perak Bridge was destroyed for the second time in 12 months. But the zero-fatality outcome demonstrated what community awareness and hard-earned experience can accomplish when people truly understand the threat they live beside. Now return to February 2026, and the scale of the current crisis becomes frighteningly clear. Following the November 2025 emergency, Semeru's explosive output surged to levels that pushed well beyond anything in its modern monitoring record. On February 9th, 106 explosions in a single day. February 10th, 101. February 11th, 92. On February 12th, 60 explosions were recorded alongside pyroclastic density currents. On February 13th, 58 explosions were accompanied by 5 separate pyroclastic flows that traveled between 2,500 and 4,000 meters down the southeastern flank toward the Besuk Kobokan Valley. On February 14th, multiple eruptions generated pyroclastic flows reaching 6 kilometers from the summit, with ash columns climbing 2,000 meters above the crater. Through the remainder of mid-February, daily explosion counts sustained between 87 and 91. By February 19, 2026, the cumulative total for the year had reached 360 eruptive events, the highest of any Indonesian volcano during that period. Each successive data point confirmed what pvmbg monitoring teams feared most. The pyroclastic flows were reaching progressively further down the mountain. The explosion frequency was climbing rather than subsiding. The ash columns were growing taller with each passing week. And the lava dome at Jonggring Seloko continued rebuilding between collapses, accumulating pressure and mass for the next catastrophic failure event. What transforms Semeru from a geological phenomenon into a potential mass casualty event is the extraordinary density of human life pressed against its flanks. More than 1 million people live within 30 kilometers of the summit. Lumajang Regency, home to the most directly exposed communities, recorded a population exceeding 1,100,000 in the 2020 national census, spread across 21 districts within roughly 1,800 square kilometers. At least 50,000 inhabitants on the eastern and southeastern ring plain are considered directly endangered by pyroclastic flows and lahars, with the nearest permanently inhabited settlements, Rowobong and Supit, sitting approximately 9 kilometers from the eruptive center. The communities most repeatedly devastated occupy the Besuk Kobokan corridor in southeastern Lumajang. The villages of Sumberwula, Supaturong, Kura, Kobokan, and Penanggal, have sustained significant damage in 2021, 2022, and again in 2025. Sumberwula scored just 39 out of 100 on a Community Disaster Resilience Index, the lowest score among all eruption-affected villages studied in the region. Yet people stay, and their reasons are entirely rational. The volcanic soil surrounding Semeru is naturally enriched with magnesium, potassium, phosphorus, and iron from centuries of eruptions, producing some of Indonesia's most remarkably fertile agricultural land. Rice paddies and tobacco fields stretch across the lower slopes, depicted on Lumajang's own official crest. Beyond farming, sand mining from pyroclastic deposits provides workers between $12 and $17 per day, significantly exceeding typical agricultural wages. Research conducted among communities on the Ring Plain found that nearly 75% of surveyed farmers agreed that the favorable growing conditions justified living with the eruption risk. Generational bonds stretching back centuries, deep cultural and spiritual ties to the mountain shared by Javanese, Madurese, and Tenggerese communities, and the inescapable economics of survival on the most densely populated island on Earth all reinforce the decision to remain. Semeru's crisis is dramatically amplified by the volcanic reality of the nation it occupies. Indonesia possesses approximately 127 active volcanoes, more than any other country on Earth, strung along the Sunda volcanic arc at the convergence of 3 tectonic plates. The entire archipelago sits squarely within the Pacific Ring of Fire, a 40,000-kilometer horseshoe-shaped belt containing 75% of the world's active volcanoes and generating 90% of the world's earthquakes. Since approximately 250 AD, Indonesia has documented between 1,100 and 1,300 volcanic eruptions and leads the entire world in eruptions producing fatalities, tsunamis, mudflows, and pyroclastic flows. Between 2000 and 2009 alone, 110 new or continuing eruptions were recorded across the archipelago. Java itself concentrates this risk to an almost incomprehensible degree. The island hosts between 35 and 45 active volcanoes along a chain running from its western tip to its eastern end, yet it is simultaneously the most densely populated island on the planet. Over 150 million people live on Java at a density of roughly 1,200 per square kilometer, approximately 30 times the population density of the United States. The island produces an estimated 75% of Indonesia's total rice output, grown in soil made fertile by the very same volcanism that threatens the farmers who cultivate it. Indonesia's volcanic history contains catastrophes that dwarf anything Semeru has produced in the modern era. Mount Tambora's 1815 eruption, rated VEI 7, remains the largest volcanic event in recorded human history. It ejected between 37 and 45 cubic kilometers of material into the atmosphere and killed approximately 90,000 people across the Indonesian archipelago, the vast majority from famine and disease in the eruption's aftermath. The following year, 1816, became known worldwide as the year without a summer, as global temperatures dropped measurably, crops failed across Europe and North America, and food shortages triggered social unrest on multiple continents. Krakatoa's 1883 eruption killed over 36,000 people, primarily through tsunamis reaching heights of 41 meters, and produced the loudest sound in modern recorded history, audible 4,800 kilometers away in the Indian Ocean island of Rodrigues. In December 2018, a relatively modest flank collapse at Anak Krakatau generated a tsunami that killed 437 people along the coasts of Java and Sumatra, without triggering any earthquake-based warning system. Closer to Semeru, Mount Merapi's 2010 eruption killed over 350 people, living just 28 kilometers from the major city of Yogyakarta. Indonesia watches its volcanoes through pvmbg, operating 74 observation posts nationwide that monitor 69 active volcanoes in real time. The instrument network includes 194 seismometers, 35 closed-circuit cameras, 59 GPS stations, and dozens of tilt meters and gas analyzers feeding data to the agency's headquarters in Bandung, West Java. The 4-level alert system progresses from Level 1, normal, through Level 2, waspada, signaling advisory status, to Level 3, siaga, meaning watch status with exclusion zones enforced, and finally Level 4, awas, demanding immediate evacuation. For Semeru, current exclusion zones at Level 3 extend 5 kilometers from the summit in all directions, 13 kilometers along the southeastern besuk kobokan drainage, and 500 meters from riverbanks out to 17 kilometers from the crater. Following the 2021 disaster, authorities also established a community-based early warning network called Simbar Semeru, linking volcano observers, local disaster agency officers, and village leaders through a shared communications platform. But monitoring systems detect eruptions. They do not prevent them. And every tool in Indonesia's considerable volcanic surveillance arsenal confronts the same immovable reality at Semeru. The lava dome at Jonggring Seloko will keep growing. Sections will keep collapsing. The pyroclastic flows will keep channeling down the same southeastern valley toward the same communities that have been buried before. The October to March rainy season, when annual rainfall on the upper slopes reaches 3,750 millimeters, compounds every threat by turning loose volcanic deposits into lahars, fast-moving mudflows capable of burying entire hamlets. In December 2025, cold lahars triggered by rainfall alone buried at least 13 houses in Sumberlangsep hamlet under 4 meters of volcanic mud. The difference between a disaster and a catastrophe at Semeru comes down to distance. In 2021, pyroclastic flows traveled 13 kilometers and killed at least 57 people. In February 2026, the longest flows reached 6 kilometers. The communities of Pronojiwo and Candipuro districts sit between 9 and 13 kilometers from the crater. If the next dome collapse generates flows at the upper range of what Semeru has demonstrated, it can produce the margin separating alert from catastrophe shrinks to minutes. The speed of pyroclastic density currents, often exceeding 100 kilometers per hour, leaves almost no time for evacuation once they are in motion. Semeru does not build toward a single catastrophic moment the way some volcanoes do. It grinds forward relentlessly through an unbroken chain of eruptions, dome collapses, pyroclastic flows, and lahars that has persisted for nearly 60 years. The instruments are recording, the exclusion zones are drawn on maps, the alert level holds at 3, and across the southeastern slopes of Java's tallest peak, more than 50,000 people continue to farm the richest soil on the island, raise their families in villages rebuilt after each disaster, and listen for the next deep rumble from the great mountain that provides their livelihood and threatens their lives with every passing day.